Welcome to the latest tutorial. In this tutorial we're going to be going over pretty much the same base content that we went over in the last tutorial, except this time I'm going to show you a way to achieve the same results in Java. Now, I talked about how it's pretty similar before when I was doing the XNA tutorial, and it's true, it is pretty similar. However, XNA helps you a bit with the API that they provide. The drawing methods are a little bit easier. They allow for instance, you can pass in a rectangle, source rectangle, which can basically just scale an image down for you. It helps with the offsets of drawing images. It looks a lot nicer and neater. But you can achieve, with a little bit more work, you can achieve pretty much the same results in Java. Now, to start, open up whatever IDE. Well, to start, I'll show you exactly what we're going to accomplish quickly. This is what we got up and running. All these tiles were drawn. As you can see, it's only this big, but that was defined from a text file, and I'm going to show you that as well. I could show it to you in this tutorial, but I think it would run a little bit long because that goes deeper into file I/O, which I'm going to discuss in another tutorial. So for this, these are rendering from actually a tile sheet, which is different from the XNA tutorial where I showed you how to render from a list of textures, individual textures. Now that way, it's perfectly okay. However, performance-wise, if you have a massive game where you're going to need a bunch of textures of tiles, you're not going to want to have a massive list containing like 1,000 textures. You're going to want tile sheets where you can quickly have your game load in a tile sheet, look where it needs to place a rectangle over to grab what it needs to draw, and then draw it quickly. And the faster your game runs, the better. You don't want a slow, fast game that where people are like, "Why is this running at 20 FPS?" You don't want that. Okay. So to start, open up an IDE. I tend to use NetBeans. You can use Eclipse. Doesn't really matter. I tend to like to use IDEs that have like some form of IntelliSense, where it will, once you type a period, it'll try and tell you all the methods available or variables for whatever object you're using. So to start, I'm going to create a new package. I'm just going to call it Tile Engine. Simple. And I'm going to start by creating a Java class called main. It's just going to be the entry point class for this tutorial. In Java, that's how you set up the main method. And quickly, to begin, well, I'm going to debug first. It works. To start, we're going to quickly set up a JFrame, which will hold our draw panel, which is going to be a J panel, which is where we'll render our graphics to, as you saw just a second ago when I showed you what we're trying to accomplish. Now, quickly, I'm going to set the size. I personally like 800 by 600. That's what XNA's default is. It defaults to 800 by 600. I'm going to set the location as well. You don't have to set the location. I just personally like to. It changes because default, when I run the program, it'll start up here at the origin of the screen. So if you set the location, offset it, it'll start around here. Better to look at. Set default. This is very important because if you don't set the default close operation when using JFrames, what'll happen is you'll go and you'll hit close on the window, but you'll see in the debugger that the application is still technically running, which you don't want. You want the JFrame to close, but you also want it to terminate. So if you pass in JFrame exit on close to the default close operation, it'll close out. Now, finally, you want to make it visible. Now if we run this, you should see, bam, we have a JFrame up and running. Pretty simple. How many lines of code was that? Not that many. So now we're going to quickly create a tile layer. Well, first, you know what? Let's create that JPanel from the draw panel, and then we'll get into the tile layer and all the good stuff. Because who cares about this stuff? Now, when using JPanels, you may find that people, for rendering onto a JPanel, JPanel and other, and swing objects like JPanel, like canvases, people will tend to override the paint method, but from what I've read, it is non-advisable to do so, because you're supposed to really especially when just working with JPanel, you should override the paint component method. So just beware of that, okay? So that's what we're gonna do. If anyone has some other comments on that, please comment in the comment section about it. Because I tend to just override the paint component method, and it works fine for me. So, of course, you must, when overriding the paint component method, call the super of that, which is basically the JPanel's version of paint component, because we're extending it. But so then, other than that, the draw panel. Before we get into that, well, of course, the draw panel needs something, right? It needs a tile layer, but we haven't created that. And before we do, I need to basically show you where you can get a tile sheet quickly. If you go to xnaresources.com, I know we're working in Java, but it doesn't really matter. This is just for this image. This is a pretty good tile sheet. Each tile image is 32 by 32, making this 128 by 32, and it's good just for this tutorial purposes. What I did also, which I don't know if you want to do it or not, because I'm gonna be covering this. What I did is I took this image, went into Paint, took it, copied it, and created basically a stack of these two together with one flipped. So instead of being 128 by 32, it was 128 by 64, and it was two of these on top of each other. And that was to test, because we're using tile sheets, you need to have a way to offset in the drawing code whether or not, when someone's inputting the map information from a text file, you need to be able to know when the drawing code needs to jump down, because otherwise, if you didn't have some sort of offset, you'd just be stuck going all the way across, which you don't want to have tile sheets that are just like 32 by 1000, because that's just not right. So you should be able to use tile sheets that go both in the X direction and the Y direction. So yes, get this image, and then we're going to start with the tile layer. So create the tile layer class. Now, like before, we had some form of multidimensional array where we held our data. In the XNA version, we used a map cell multidimensional array, map cell being a class that we wrote ourselves. In this tutorial, I'm going to keep it strictly to the regular 2D array of integers. I think it's simpler. I'm just showing you basically how to render. You can extrapolate from there. Especially the XNA version, I had an idea about doing, having each map cell hold a collision ID, But if you were ever to extrapolate this and make it into like some sort of engine where you had a tile editor, you would be, the real way you do it is you'd have something called a collision layer, which might be a tile layer, might come from a tile layer, might extend a tile layer, that would hold all the collision information. Because if one tile is collidable, then everything on it is collidable. It's not 3D, it's 2D. So basically, the way we did it in XNA was a little bit overkill. So here I'm just keeping it very low key, very simple, and you can do with it what you like. So to start, I'm just going to start with map. That's how you create a 2D array, a map. So, and also to draw, we need an image, and like the image we just got, which was this, we're going to need something to store that in. And images, there's two things you can do. You can either use an image, or you can use buffered images. We're going to use a buffered image. Call it a tile sheet. Sounds better. Now we're going to do a constructor. Now, the standard constructor, if you've watched the XNA tutorial, of course, takes the existing map. And you might, if you watch the XNA tutorial, you might be able to do this yourself. But for people who didn't, we need to initialize map so we can actually use it by setting the length, the rows and columns, basically, to the existing maps. And the way we do that is this. Now, this might make sense. Existing map.length, that's down, that's downwards. How many stacks there are, basically the height of this existing map. Now here, we're using 0 because it really doesn't matter. We could use 1, we could use 2, but to be honest, actually, you might not be able to, because you don't know how many stacks there are. You don't know how bit taller or whatever it is. So you need to use 0. But basically, this is just to get how many across it is. So how long in the x direction it is. That's how you get that length. So now we have the map initialized. We need to loop through it. And this is basically a manual copy. We're manually copying the values in map, existing map into map, because we want those IDs that we set. And as you can see, NetBeans, I don't know about if Eclipse does this, but NetBeans actually will tell you that what you're doing is actually a manual array copy, which is A-okay. It's A-okay. There's nothing bad with doing that. Now, the next method we're going to create is draw layer, which will take graphics, G. Now, the draw layer method, very, very similar, or somewhat similar to the XNA version. Again, you're just going to loop through, same loop as always. Kind of gets, monotonous and tedious at times, but it's fun. I enjoy programming, so I don't care. So now that we have this, of course, like before, we need the index. We need that value. I mean, there's no point in having the map. We're not going to get the values from it. So we have this index, and basically, like I said before, that's probably not a good example of it, but right here, this is what I did with that image. I stacked it, I flipped it and stacked it. Now, the problem with just standard without any offset draw code is what if you want to draw something down here? What if you have a tile sheet that's stacked? You need to have a way to know when it gets, if you pass in, let's say 4 is the index, 0, 1, 2, 3. What does it do once it gets to 4? If it didn't have some sort of offset, it would try drawing this, which doesn't exist, so it will draw nothing. You need to have it jump down to here, basically, and reset the index, keep in mind, because it can go and drop down to the Y offset. The source rectangle can drop down, but then the index would stay the same. So you need to set the index back to know that it's supposed to go here. So here we go. Basically, you're going to need an integer for the Y offset, which you can pretty much just set to 0. And then you need a little if statement right here. If the index is ever greater, so if this index is ever greater than the tile sheet dot get width. So basically 128 in this instance, the width is going to be 128 in pixels. Now, if we divide that 128 in pixels by, well, you know what? What do we divide it by? Let's create a quick class called engine, where basically we're gonna, like before, and if you've seen the XNA tutorial, we did this in that one too. We create these quick integer values that are going to stand for the height and width of each tile. So if you look at this image, each of these are 32 by 32. Keep in mind this whole style of tile engine requires that each image be the same width and height. You can't have one that's any bigger than what you set it as in the beginning, what these values are, these constant values are, which is fine. This is how a lot of the old style tile engines did it. If you go back and play some of the really early 90s, late 80s NES RPG games, you'll see that a lot of the tiles, pretty much every tile, is the same width and height, which is a testament to the great art, 2D artists that they had to be able to draw stuff and split it up into perfectly meshing tile sets. So basically, now that we have that class, you'll be able to do that. So now this, if you think about it, you'll get 128 divided by 32, which will be 4. But technically, the index starts at 0, so you're going to have to subtract 1 from that to have this even work. So that this is perfect for this loop. Basically, if the index is ever greater than that value, which was 4 minus 1. So if the index is ever greater than 3, which is fine because 0, 1, 2, 3, that makes sense. If it's ever greater, if it ever ends up being 4, now we're going to have to handle the offsets. So what do? Well, first, might as well go f offset plus plus. So there you go. So now you've increased this value, which is fine. So now, here's the thing. Now it's gone down. It went down here, except the index is still 4. That hasn't changed. So it's just going to be down here, but it's still going to be drawing nothing because the source rectangle is going to be over here. What you need to do is set the index back over here. Now to do that, if you think about it, the index is 4, right? So how are we going to get it back to 0? Well, we just said that the width of this 128 divided by 32 is 4. So how about we try, whoops, clicked the wrong thing. How about we try setting the index equal to index minus, which is 4 at the time, or it could be 5, it could be whatever. It'll adapt to whatever the index is at the time. So, or however wide the tile sheet is. You go tile sheet dot get width divided by engine dot tile width, and there you go. So the index now is reset. So now let's say I want in a text document to draw this tile. What I'll say to it is I'll say 4. I want to draw tile 4. I'll type it in number and it'll pop out this. Tile 5, pop out this. If you think about it, you know, you're gonna yeah. If you think about it, yeah, that'll work. You just have to always in computer science in general, in computers, you always have to think about how counting seems to start at 0 with most things. It's 0-based counting. So you may think, oh, I want tile number 5, so I put 5, but no, that's going to give you that because it's 0-based counting. So you always have to think it's one less from what you want. So here we go. The sign value is never used. We're going to use it pretty soon. Don't worry. Finally, the final step in this. It's a lot more code than X and A, as you can already see. We're going to need to use one of these draw image methods. Now, if you can see, NetBeans gives you a little bit of information about them. This one we don't want to use. 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 Why? Because none of them seem to have anything about source rectangles. Now, if you look at this one, as you can see, it takes in the image, our buffered image. It has a bunch of dx, dy, dx2, dy2, all these different integers. Now, if you can see, draw as much of the specified area of the specified image as is currently available, scaling it on the fly to fit inside the specified area of the destination drawable surface. So, this is pretty much the one we want. The image observer, you don't have to worry about. That can just be null. Does not matter. Here's where it gets really tricky. We need to know and tell it where we really want to draw each image for the destination. Then these other values right here, these 4 values are the source of it. These are going to be destinations of each corner, these 2 corners of each rectangle, of each tile within the tile sheet, where we want to keep moving it when we want to draw. So it's more complicated because the documentation's funny. You can even see the documentation here. The x-coordinate of the first corner of the source rectangle, the y-coordinate of the first corner of the source rectangle, second corner. It confused me at first, but I finally got it. And here's how you do it. We are going to need to plug in some values. So the first of this right here, this x, it's pretty convenient because we're going to actually be using the variable x from up here. Now, to start, for the first destination, we're going to multiply that by engine dot tile width. So that's how that's going to work. Basically, we can hit enter and start on the next one. So for that, you have x times engine.tile width, and that's basically, like I said before, that's to shift the drawing across, so it's not drawing over itself, like in the same spot. And we're going to do the same thing for, of course, the y. Now, after that, it begins to get a little bit tricky because we're going to need to shift it over, but it's looking again for we just gave it that top corner, and now it's going to need to find this. So what we're going to have to do is pretty much do the same exact math, but just one extra thing. And that's, we have to add on the engine.tilewidth. We have to add that on to it, because as it's moving over, as it's drawing over, we gave it this right here, that corner, but now it needs this. So that's this plus 32 plus 32 down here, 32, 32. Of course, multiplied by x. So let's say we're going for, 64 by 64 or whatever, or 32 by 64. We're going to be moving over. So that's the convention of that. Same exact thing for y. Oh. Tile height. Now, those are completely done. That's all the destination stuff. We figured that out. Now, here's where the drawing specific stuff is coming in with the source rectangles. And this is where it gets a little bit fishy, because we're going to need to account for the index. We're going to have that in there. We're going to have this y offset that I've been talking about. So, right here, we're not using these x or y values. What we're going to be using is, for the first, we want the index times engine.tilewidth. Now this should give us, let's say the width is, the index is 0. So 0 times 32 should just be this value right here, 0. Let's say it's 1. 1 times 32 should be over here, 32, and so on. So there should be no problem with that, mathematically. Now, for the next here's where we're going to have this y offset. Now, we have to account for this y offset because, let's say we are on the second, well, let's say on the first one, the y offset is going to be 0, so it's not going to matter. We're going to get right over here, we're going to get the same thing. We're going to get, we're just going to get, 0 or whatever. So, but if it's 1, we want to be down here. We want to be down at this corner getting this, rather than up here getting this. So that's why we have to account for this y offset and put it in there, times engine.tileheight. So there we go for that. That's the first half of the source rectangle conundrum. So now, similar, pretty much in the same fashion as up here, how we got that corner, and then we need to get the corner straight across from it down below. Right here we got the upper left corner, and now we need the same thing, but we need to get the lower right corner. So to do that, you might guess this same, I'm just going to copy and paste it. That's how similar the code is. Boom, there you go. But one more thing, we just need to add the tile width. And then finally, in same fashion, what we're going to have to do is do the same thing for this. We need to get that y offset. Whoa. Get that y offset, right? But then we're going to have to add the tile height, and that can stay null. That is fine. That can stay null. So this should cover all of our drawing code, and that should be all we need for that. Now, for the loading the texture, because of course we're going to need a way to get a texture into the program. It doesn't just magically appear, and we can't just set it. We have to set it to something. So we're going to create a quick method that's going to return a buffered image, basically called load tile sheet. And I'm just going to pass it in a string file name. So for this, first we're going to start off with an image, set it to null. So now this, you see there's no errors in this. Now to load stuff using image.io, file.io, it doesn't really matter. You need to have things called try and catch statements. So you're going to, which basically are for in case something goes wrong. With the loading, whether or not it can't get it's weird. Basically is equal to, we're going to be using image.io, and there. See, now there's no more errors with this try. Any image.io or file.io requires you to have it in a try and catch statement. That way, if there's anything wrong with the loading of the image, we can actually just print to the debug, to the console, some sort of error message like, could not load image. There. So this should be perfectly fine. This should load the tile sheet fine. Now, to use this constructor, we're just going to quickly set this is what I named my tile sheet. Now, I recommend you use JPEG because there's a limited number of supported image types that Java uses. I know JPEG's one of them. I think PNG might be another one. I'm not positive, don't quote me on that. But not all types of images are supported in Java. Of course, you can find a way to get them to be supported, from writing your own importer, but that's that. So now that we have this all done, we can go into the draw panel and create a tile layer for us to use. Actually, we can make it private. Of course, let me repeat that this right here, I'm just doing this for tutorial purposes. I would not recommend just loading, some specific image file into the tile sheet as the tile sheet for the tile layer. When I teach you how to load from text file, I'm going to show you how to from the text file, name certain tile sheets and load them into an array list and figure out a way from there to decide what tile sheet should be used. But that's for a later tutorial because it's quite complex. But for now, this is just fine for this specific tutorial. So quick, we're just going to create a simple constructor that pretty much does nothing except for set this tile layer. Something quick. It's just for testing purposes. I'm just throwing up a quick multi-dimensional array into this because if you remember, that's the constructor we made. Now, in this, we should be able to just do that and have it work. Now, one last thing is in the main. The frame has a method called frame.setContentPane that takes a container called ContentPane. Now, JPanels are technically containers. They're a type of container because they are not only a container, they are a J component. So they can be thrown in here as the content pane. So that's the method we're going to use. But first, of course, we need to actually set up the panel. Test in panel. Now, moment of truth, this should work, and we'll see if this works. So let me see. Okay, moment of truth. No, what happened? Oh, here's one thing I forgot to mention. I know what the problem is. Remember how we're loading in this picture? I never actually put it into the directory for it to be loaded. So basically, for NetBeans, the default directory is right here. When you click on your project, if you drop any sort of text file or image file that you're just loading directly in, you're not actually giving it a file path, the default file path is right here. So what I'm going to do is copy, paste, to PNG. Quickly, I'm going to go open with paint file, because remember I said about so I'm just going to save it right in here as a PNG. Save. So now we have a PNG version. I'm going to delete that version, and well, we have a JPEG version. And moment of truth, boom, there it is. So as you can see, we gave the map in the draw panel we gave it a bunch of indexes for the zeroth element. So here we go, 0. Now we can change this to 1 if we want, and it should draw fine. There you go. There's the second in the tile sheet. 2. There's the third in the tile sheet. Boom. The 2. Zero-based counting. Remember. And you can even I can even say 4. And as you remember, it's stacked. So if I tell it 4, it should give me this. Boom, there you go. You might think, hey, what? Maybe it's giving you that. No, because watch, I'll change it to 5. Boom, it's giving me that. So it's working. The offset's working. Everything's working correctly. So using this, you can draw, massive maps. Whoa. Shouldn't happen. Oh, you know why that's happening? Because there's no commas in between. But yeah, you can start drawing big maps. Now, in the next tutorial, I'm going to show you using file IO in Java, how to read in a text file and get all the information from the text file, splitting it by spaces or by commas, whatever you feel is best. Spaces I like because it's neat. There's less stuff. Commas, just more stuff in the way. Yeah, so I hope you liked the tutorial. There'll be more coming soon. Thank you.